Hello and welcome. There are several types of functions in mathematics. From these types, the injective and surjective functions, so, in this lesson, we will study them, with some examples. At the beginning, if we have a function, f from R to R, and it is defined by f of x equals 2x plus 1. This function is called a linear function, and we know from the previous lesson that the domain of the function is the input values of x, for which the function is defined. In other words, it is the set of all possible values that you can substitute into the function, without causing any mathematical issues, like division by 0, or taking the square root of a negative number. Thus, the domain of this function is the set of real numbers R. Let us take some of its elements, like -1, 0, 1, and 2. And we also know that the range of the function is the set of the images of all elements in the domain, that is, the output values of y or f of x. And for this function, its range is also the set of real numbers R. And we will take some of its elements, like -1, 1, 3, and 5. Then, begin with x equals -1, substitute with it in this function, so f of -1 equals -1, and f of 0 equals 1. And substitute x with 1, thus f of 1 equals 3, and f of 2 equals 5. And here, 3 is not equal to 5. Whenever 1 is not equal to 2. And what are you notice in these arrows? Yes, every arrow go from only one value to only one value. That is, this function is a one-to-one, or injective function. So, the function is said to be a one-to-one function if each element in the domain has a distinct image in the range. In simple terms, no two different inputs produce the same output. Or, for every input, there is a unique output. That is, if f of x1 is not equal to f of x2, whenever x1 is not equal to x2. Also, the one-to-one function will not have any horizontal line that intersects its graph more than once. Let us take an example, for a function is not one-to-one. If we have a function, f from R to R, and it is defined by f of x equals x squared. Thus, the domain of this function is the set of real numbers R. Let us take some of its elements, like -2, -1, 1, and 2. Its range is also the set of real numbers R. And we will take some of its elements, like 0, 1, and 4. Here, f of -2 equals 4. And f of -1 equals 1. And also, f of 1 equals 1. And f of 2 equals 4. And here, 4 equals 4. But, -2 is not equal to 2. And what are you notice in these arrows? Yes, the arrow go from different two values to the same value. That is, this function is a many-one function. So, the function is said to be a many-one function, if two or more different elements in the domain can map to the same element in the range. This means that the multiple inputs can produce the same output, but each output corresponds to at least one input. That is, if f of x1 equals f of x2, then x1 is not equal to x2. Also, the many-to-one function will have a horizontal line that intersects its graph more than once. Now, let us study the surjective function by an example. If f of x is equal to x cubed, also here, the domain of this function is R, and its range R. And we will take some elements from the domain and range, as before. Here, f of -1 equals -1. And f of 1 equals 1. And f of 2 equals 8. And what are you notice in these arrows? Yes, every arrow go from only one value to only one value. And every possible output value has a corresponding input value. So, the function is said to be surjective or onto if every element in the range is the image of at least one element from the domain. That is, for all y belongs to the range R. There is some x belongs to the domain R, with f of x equals y. And also, this function is a one-to-one, where f of x1 is not equal to f of x2. Whenever x1 is not equal to x2. And since the function is onto and one-to-one, thus, it is called a bijective function. Now, our lesson of today is finished. See you later in the following lesson.